The trucks came without warning. Their engines roared as they pushed deep into Costa Rica's Guanacaste conservation area and dumped 12,000 tons of orange peels. These weren't ordinary vehicles. They were on a bizarre mission. But years later, they returned to see the results. As the truck ground to a halt, its back opened. A cascade of orange peels tumbled, covering the ground in a thick, sticky carpet. The air was filled with the overwhelming scent of citrus. But this wasn't a single truckload. More trucks followed, then more. Soon, the quiet forest clearing was buried under a mountain of discarded fruit rinds. Local animals watched in confusion. Birds circled overhead, curious about this new addition to their home. But amid the chaos, two ecologists, Jansen and Hallwachs, watched anxiously. For them, this wasn't destruction. It was the start of a daring experiment, one that could either revitalize a degraded ecosystem or spell disaster for the protected land. Jansen and Hallwachs spent years working in Costa Rica. They fell in love with the country's incredible wildlife. Costa Rica may be small, but it's home to 6% of all the world's plants and animals, an amazing biodiversity they wanted to protect. This wasn't just a professional partnership. Daniel Jansen and Winnie Hallwachs were a husband-wife team. They graduated from Princeton in 1976 and became ecologists at the University of Pennsylvania. But their hearts remained in Costa Rica. They worked together as researchers and advisors at the Área de Conservación Guanacaste, ACG, or Guanacaste Conservation Area, for many years. The couple noticed a big problem while working in Costa Rica. Many areas that used to be lush forests had been turned into cattle pastures. These pastures were now dry and almost lifeless. The ecologist couple wondered if there was a way to bring these areas back to life. This challenge became their life's work. They focused on finding ways to save endangered tropical forest ecosystems. They knew these forests were home to countless plants and animals found nowhere else on Earth. If the forests disappeared, so would these unique species. In 1995, Del Oro built an orange juice factory close to the conservation area. Most people thought this would harm the forest. Factories often bring pollution and cut down trees for space. But Jansen and Hallwachs looked at the situation differently. They learned that Del Oro faced a big problem. When you make orange juice, you only use the inside of the orange. The peels and pulp get thrown away. For a factory as big as Del Oro's, this meant tons of orange waste every day. Getting rid of this waste costs Del Oro a lot of money. The company tried different ways to deal with the waste. They could send it to dumps, but this was expensive. They could burn it, but this would pollute the air. They could leave it to rot, but this would attract pests and create bad smells. Jansen and Hallwachs devised a bold plan. They would let Del Oro dump its orange peels in the conservation area. Del Oro would exchange some of its land for the conservation project. It sounded crazy, but Jansen and Hallwachs believed it could work. They had studied forests for many years. They knew that most plants need good soil to grow. The problem was that parts of the conservation area had very bad soil. Years of cattle grazing had taken away most of the nutrients plants need to survive. These ecologists noticed something interesting about orange peels. When orange peels rot, they turn into soil. This happens the same way dead leaves break down in a forest. The nutrients found inside these orange peels are essential for plant survival and growth. The main nutrients are nitrogen, potassium, and phosphorus. Nitrogen is like food for plants. Without it, plants can't make new leaves or stay green. When you're hungry, you need food to grow and stay healthy. Plants need nitrogen in the same way. Potassium helps plants build strong stems. Just like humans need calcium for strong bones, plants need potassium to stand up straight and not fall over. Phosphorus goes straight to the roots. It helps plants grow strong roots that can reach deep into the ground for water. The deeper the roots can go, the better a plant's chance of survival when there isn't much rain. As the orange peels break down, these nutrients mix with the soil. Rain helps wash them deeper into the ground. Plant roots and drink this nutrient-rich water like a healthy smoothie. The old soil in this area lacked nutrients, making growing plants like growing them in sand. But when the orange peels break down, they make the soil rich in plant food. Over time, this new soil will help more plants grow. The pile of orange peels will also do something else important. It will cover the ground completely, which stops sunlight from reaching invasive grass below. This grass had been taking all the water and nutrients, making it hard for other plants to grow. When the grass died under the orange peels, it left room for new plants to grow. They knew it was a big risk. They could damage the forest they were trying to protect if they were wrong, but they also knew that if nothing changed, the poor soil would stay poor, and few plants would grow there. They decided it was worth trying something new. Of course, they couldn't let the company dump anything it wanted. They set some important rules. Only agricultural waste, like orange peels and pulp, could be dumped. No pesticides were allowed on the crops. The peels had to be cleaned with limonene oil. That was really important. Limonene naturally stops plants from growing near orange peels. It's like nature's weed killer. By removing it, the peels could now help plants instead of stopping them. And the dumping could only happen in areas that used to be cattle pastures. Del Oro agreed to these rules and was happy to eliminate its waste for free. Plus, they'd help the environment. The company agreed to bring their orange peels to the conservation area. The plan was big. Del Oro would send 1,000 trucks full of 12,000 tons of orange peels each year. They would keep doing this for years to come. When you add it all up, that's 250,000 tons of orange waste. To understand how much that is, imagine filling up an entire football stadium with orange peels. The experiment began in 1998. Trucks started bringing loads of orange peels to the designated area. The sight didn't look good at first. Orange peels were everywhere, and the air smelled strongly of citrus. Some people held their noses when they walked past. Others said it looked like a garbage dump instead of a conservation area. But the ecologists weren't worried. They knew nature needed time to do its work. They put up yellow signs to mark where they'd dumped the peels. They also took pictures and wrote down what the area looked like. For a while, everything seemed to be going well. The orange peels started to break down, the strong citrus smell faded, and small plants grew in some areas. It looked like the experiment might be working. But then the trouble started. Another juice company, Tico Fruit, got angry about the project. Tico Fruit had to spend a lot of money to get rid of its waste, and it didn't seem fair that Del Oro could dump it for free. Tico Fruit didn't waste any time. They launched a big campaign against the project in 1998. They bought ads in newspapers and on TV. The ads showed pictures of the orange peel piles and called them mountains of rotting waste. They said bugs were breeding in the peels and spreading to nearby farms. They even claimed that bad smells from the rotting peels were making people sick. The campaign worked. People started writing angry letters to newspapers. Local farmers worried the rotting peels would attract fruit flies that would damage their crops. Environmental groups that weren't involved in the project started asking questions. Even though there was no proof that the peels were causing any harm, people were scared. Tico Fruit then took the fight to court. Their lawyers made three main arguments. First, they said dumping waste in a national park was illegal, even if it was just fruit peels. Second, they claimed the deal between Del Oro and the conservation area wasn't fair to other companies. Third, they argued that the project could encourage other companies to dump their waste in protected areas. The ecologists fought back. They brought in scientists who explained how the orange peels could help the forest grow. The Rainforest Alliance, a respected environmental group, supported the project. They showed data from similar projects in other places where fruit waste had helped restore damaged land. Del Oro also defended themselves. They proved they were following all the rules set by the conservation area. The peels were clean and free from chemicals. They were only being dumped in areas already damaged by cattle grazing. The court case went on for several months, and it even went all the way to the Supreme Court. By the time the court decided, about 12,000 tons of peels had been dumped. That's about the weight of 2,000 elephants. The peels covered an area as big as 3 football fields. Finally, Costa Rica's Supreme Court made its final decision. They ruled that the project had to stop. The judges said that even though the project might help the environment, it was setting a dangerous example. They worried other companies might use this case to justify dumping different kinds of waste in protected areas. The decision was a big blow to Jansen and Halwax. They had to stop the project immediately. The area where the peels had been dumped was left as it was, and no more peels could be added. The ecologists were disappointed but had to obey the court's decision. After the court case, people mostly forgot about the orange peel project. The area where the peels had been dumped was left alone. No one was allowed to interfere with it. Years passed, and the site became overgrown. It was hard to even find where the peels had been dumped. As time passed, the story of the orange peel dump became a kind of legend among ecologists. Some people said it had been a disaster, with the peels attracting pests and causing problems. Others claimed it had worked miracles, turning a barren pasture into a lush forest. But no one knew for sure what had happened. 16 years passed. The world had changed a lot since the orange peels were dumped. People were more worried than ever about the environment, and climate change had become a big concern. Scientists were looking for ways to regrow forests and remove carbon dioxide from the air. In 2014, a team of researchers from Princeton University heard about the old orange peel experiment. They were intrigued. Could dumping fruit waste help regrow forests? They decided to find out. The team, led by a young scientist named Timothy Truer, planned a trip to Costa Rica. When Truer and his team arrived in Costa Rica, they had trouble finding the old experimental site. The landscape had changed so much in 16 years. They searched for days, using old maps and GPS coordinates. Finally, they found what they thought was the right area. But something was not right. Where they expected to find a field full of rotting orange peels, they instead found themselves in a thick, lush forest. They were confused. Had they come to the wrong place? They searched the area, looking for any sign of the old experiment. As they pushed through the dense vegetation, one of the researchers spotted something yellow in the distance. They made their way towards it, fighting through vines and branches. When they got closer, they realized it was an old sign, almost completely covered by plants. This was one of the signs Jansen and Hallwax had used to mark the experiment site. The researchers had found the right place after all. They were standing in the middle of the old orange peel dump site. The team was amazed. The barren cattle pasture where the peels had been dumped was now a thriving forest. They could hardly believe their eyes. There was no trace of the orange peels. Instead, there were tall trees, thick undergrowth, and various animals. The research team knew they needed solid evidence to prove what their eyes were seeing. They couldn't just say, "This place looks amazing." They needed real data, so they got to work. First, they looked at soil samples from 2 different times. Laura Shanks from Beloit College collected the first samples in 2000, just a few years after the orange peels were dumped. Then Jonathan Choi collected new samples from the same spots. By comparing these samples, they could see how the soil had changed over time. The team then set up measuring stations throughout the forest. They marked out straight lines that were 100 meters long, about the length of a football field. Along these lines, they measured every tree within 3 meters on either side. They noted each tree's thickness and figured out what species it was. But they needed something to compare their results to. So they went to the other side of the road where no orange peels had been dumped and did the same measurements. This way, they could see the difference the orange peels had made. The results left no room for doubt. The forest that grew from the orange peels differed utterly from the nearby regular forest. The soil was packed with nutrients that plants need to grow. There were more trees, and those trees were bigger. They found many different types of trees growing together, creating a thick canopy of leaves overhead that blocked out the sun. In fact, there was 176% more plant life in the orange peel area than in the untreated land nearby. They saw a big fig tree that took 3 people to wrap their arms around. The researchers identified 24 different types of trees in the orange peel area. This was amazing compared to the untreated land nearby, which only had 8 types of trees. The soil in the orange peel area was also richer and healthier. The orange peels didn't just help trees grow, they helped the whole forest ecosystem come back to life. They spotted animals that usually avoid empty grassland, like the tyra, a large forest weasel that needs a healthy forest to survive. These animals showing up was another sign that the orange peels had truly transformed the area into a natural forest. The researchers were excited to share their findings with the world. They included detailed measurements, soil analysis results, and comparisons between the orange peel site and untreated areas to ensure other scientists could understand exactly what happened here. When they published their paper, news spread quickly through the scientific community. Many researchers were amazed by what they saw. Here was proof that agricultural waste, which usually costs money to eliminate, could help rebuild forests. Some scientists did ask tough questions about the research. Could the forest have grown back on its own? What if the orange peels had nothing to do with it? The research team had an easy answer. They just pointed to the land right next to the orange peel site. Both areas had the same climate, weather, and starting conditions. The only difference was the orange peels. After 16 years, the difference between the 2 areas was impossible to ignore. Another significant finding was revealed by the study. Usually, when people try to regrow forests, it costs a lot of money. They have to buy young trees, plant them by hand, and often add expensive fertilizer to help them grow. But this method was different. The only cost was trucking in the orange peels, which the juice company would have had to pay to dispose of anyway. The rest happened naturally. The success of the Orange Peel Project has inspired scientists to look for other ways to use food waste to help the environment. Some research has been conducted on the conversion of orange peels into car fuel. Others are trying to make plastic from orange peels to replace regular plastic that pollutes the environment. Companies are getting interested too. Some food producers are looking for ways to use their waste to help the environment instead of just throwing it away. This could be good for the planet and save the companies money. But it's important to remember that this method won't work everywhere. Costa Rica's warm, wet climate helped the forest grow quickly. In colder climates, the process may be slower or ineffective. Dumping any kind of natural waste needs to be done very carefully and with scientific guidance. For Jansen and Hallwachs, the result of their experiment was a dream come true. Even though their project was stopped early, it still had amazing results. Their creative thinking turned a problem, too much orange waste, into a solution for restoring forests. From thousands of orange peels to a thriving forest, nature can do amazing things if we give it a chance. The orange peel forest shows us that solutions to big problems can come from unexpected places. By thinking creatively and working with nature, we might find ways to solve environmental problems using things we usually throw away. What do you think? Could this method work in other places? What other waste products might help regrow forests? The story of the orange peel forest challenges us all to look at the world differently. Next time you eat an orange, think about the peel. It might not be waste. It might be the start of a forest.